This sample is going to help you make some calculations with regards to specific heat. And as we learned in section 13-2, specific heat indicates how easy or how difficult it is to heat up a certain substance. So for example, a metal like iron or gold would be very easy to heat up and also to cool down. Therefore, it has a very low specific heat. Something like water, which is very difficult to heat up or cool down, will have a higher specific heat. So the formula that we're going to start with is this: Q equals MC times delta T. And let's go over what all of these things stand for. Q stands for heat. That's the amount of energy that's being transferred from one object to another. The unit that we're going to use for heat is called joules, right? And we use a capital J to indicate joules. The M in our formula stands for the mass of the object or substance. The unit that we use for mass is kilograms, okay? Not grams, but kilograms. So remember, a kilogram is 1,000 grams, and we may have to do some converting, okay? Little c, is the specific heat of the material, and every substance has a different specific heat. It's a physical property of the matter, and so we'll always give that to you unless I'm asking you to solve for it. So there's a table in your book on page 432 that indicates the specific heat of all of the substances you'll need for my class. You can always look this up in some other sort of table on the internet if you need an alternate source, but just use your book. It's the easiest thing there. Now, the units for specific heat are a little bit weird, but if you just write them down and just use them, it's fine. It's joules over kilogram degree. So I'll show you how that works out in a minute. The last player here is delta T. Now the delta, that's a Greek letter delta, this triangle here. Delta always means a change in, and then our T means temperature. Okay, so not the beginning temperature, not the final temperature, but the change in temperature. So if I started out at 5 and went to 50, my change would be 45 degrees. If I started out at 100 and went down to 60, my change would be 40 degrees. So it doesn't really matter which way you're going. When you get to chemistry, that'll be a little bit different story, but for now, that's okay. Now, the thing you've got to remember here, that this temperature change has to be in Celsius degrees or in kelvins, okay? If you remember, the difference between the amount of 1 Celsius degree and 1 Kelvin is the same. So it does, for a change, it doesn't matter. No Fahrenheit, okay? We did learn how to convert back and forth from Fahrenheit, but really only because that's the temperature we use in America. When you're doing a problem in science, always degrees Celsius or kelvins. When you get to chemistry, your teacher will explain when you can only use kelvins, but for our class, either one is fine. Okay, so there's our formula. There's what everything means. Let's try a problem. Okay, so the sample on page 433 says, how much energy must be transferred as heat to the 420 kilograms of water in a bathtub in order to raise the water's temperature from 25 to 37 degrees Celsius? So when I do a problem like this where I'm going to have to use a formula, I set up my data table. So the 4 things I need to deal with are Q, M, C, and delta T. So I write Q equals and blank, M equals, C equals, and delta T equals. So what I'm going to fill out here is either the data that I have, or I'm put a question mark if that's what I'm looking for. So let's read the problem again. How much energy must be transferred as heat to the 420 kilograms of water? That's the mass. So I'm going to put my 420 kilograms right here. 420 kilograms of water in a bathtub in order to raise the water's temperature from 25 degrees to 37. So I can find the change in temperature, right? It's just 37 minus 25, so that's 12 degrees, or 12 kelvins, either way. Now, it does say how much energy must be transferred as heat. That's my question mark, so I'm going to put my question mark next to Q. Well, that says, well, I need to find the specific heat, and they didn't tell me that. Remember the table from page 432, okay? The substance we have is water. So I go to my table on page 432, and I find water is the first thing on there. And the specific heat is 4,186 joules per kilogram degree. All right, so that's my first step. And if you have trouble with word problems, I guarantee this will help. Okay, identifying what you have, identifying what you need. Now we're going to find a formula. Okay, and we only know one formula, and it's this one. Q equals MC times delta T. So we've already solved for Q. I don't need to solve for it. Let's just plug in our numbers. So I plug in the numbers, including the units. So 420 kilograms for mass. For my specific heat, I'm going to do 4186 joules per kilogram degree. And for my temperature difference, I'm going to put 12 degrees. Okay, now look at this like a math problem where you're canceling out variables. You can cancel out units the same way. So you notice I have a kilogram up here and a kilogram down here. I can cancel those out. I also have a degree down here and a degree up here, so I can cancel those out. And so I'm going to be left with units of joules, which is what I want for heat. Okay, so that can be very helpful. So then your calculator, you plug in 420 times 4186 times 12, and you get, and this is rounded, forgive me, I didn't write down the actual answer, about 21 million joules. Right now, at this point, I'm absolutely fine if you just write down whatever's on your calculator. If you're comfortable converting to scientific notation, that's wonderful. And we will talk about that in class. But if that is too much for you to do, just make sure you get the number and the unit and we'll be fine. One other thing I wanted to discuss before I stopped this is, what if I ask you for something else? What if I ask you for the mass? How can I solve this formula for the mass? Well, I can do that by dividing both sides by C delta T. And I get M equals Q over C delta T. So it's not another formula, it's just another way of writing that formula in case what I asked you for was the mass. Well, what if I ask for the change in temperature? Well, we can do the same thing. I can divide both sides by MC, and I can get delta T equals Q over MC. So that's my formula if I'm looking for the change in temperature. Now, if I look for a change in temperature, sometimes I might be told the beginning temperature and the final temperature, and I've got to sort of figure it out. But that's how you can find the change in temperature. And then finally, what if I'm asked for the specific heat of something? Well, I can divide both sides by M delta T, and I can get C equals Q over M delta T. So if manipulating the algebra is tough for you, or it takes a long time, or you're prone to mistakes, just write down all four of these formulas. And then when you're asked for whatever you're asked for, you just say, oh, well, you just got to pick, I am asked for Q, I'm going to use this one, or I've asked for M, I'm going to use this one, etc. So that's my example on specific heat. I hope that helps you to do the problems on page 434, and I will see you soon.